Now, when you're paying off a loan, there's four things that you might need to find. There's the principal amount that you borrowed, the interest rate, the amount of your repayments, and the length of the loan. And you can be asked to find any one of those if you know the other three. So in this example, we're finding the length of a loan. So Emma borrows $10,000 to buy a car at 6% per annum, and it's compounded monthly. Notice I'm highlighting the important parts. She repays $300 at the end of each month. That's important too. How many months will it take to pay the loan off? Now, we need to develop a formula for the amount that she owes at any one time, and then we can let that formula, that AN, equal 0, because when we've paid the loan off, she'll be owing nothing, and we can solve for N. All right, so first thing I'm going to do is make sure I get my interest rate right. 6% per year is the same as what per month? How do you find it? You divide by 12. Now, if you have trouble with doing this step and coming up with R, I recommend putting 6% into your calculator using the percentage button, hit equals, and then divide it by 12, because this is 0.5% per month. But when you convert it into R, it's really easiest if you can do this as a decimal. So I know that 1% is 0.01. That's what I sort of work on. And then to get it right with 0.5%, I know it's half of that, so I need to go another 0. I also do little checks like thinking, okay, I've got to move the decimal point across 2 because this is percent and percent is out of 100. Dividing by 100 moves it across 2. But if you just put this in your calculator, divide by 12, this is the number that will drop out. So if this is an area that you make mistakes, just use your calculator for it. All right, now every year that the interest gets charged, we need to multiply it by 1 plus the rate just for that year. So we're effectively using the compound interest formula that looks like this, but we're just applying it for each year, 1 year at a time. At the end of the first month, let's call that amount A1. What are we going to have? Well, Emma borrowed $10,000, so she owes all of that. Now, the bank is going to charge interest at the end of the month, and she's also going to make her repayment of $300 at the end of the month. Which thing's going to happen first? If you have trouble remembering, imagine that you're the bank manager. You're trying to make the amount that's owed as much as possible. So you're going to charge Emma interest, 1 plus the rate, which I can write as 1.005. You're going to charge her interest first, and then straight after that, she's going to make a repayment. Because picture what would happen if she made her repayment first, then you'd only be charging her interest on $9,700. And the bank wants to charge her interest on the whole $10,000 that she's borrowed for this whole month so far. So they charge the interest first, and then she makes the repayment. That's how it works. Now, I could put this in my calculator and figure out what it is, but I don't want to do that. Whoops. Because I want to come up with a pattern for AN. So I'm going to leave it in this form. Now, at the end of the second month, Emma still owes all of that same money. So I'm just going to write the whole thing out again. A little bit tedious, but this is what we have to do. And the bank says, right, how much does Emma owe? All of that. We'll take that whole lot, put it in brackets, and let's charge interest on it. To charge interest, we multiply it by 1 and a bit, and that's our bit. Then Emma makes the repayment. Now, we can tidy this up a little bit. Let's expand these out to brackets. Inside the brackets, we've got 2 terms, and we can multiply both of them by this. So this first term becomes 10,000, 1.005 squared, and the second term will be 300 multiplied by 1.005, and then we've got our minus 300. So that's a better version of A2. Let's put a box around that one because it's the one that we want to use. All right, at the end of the third month, Emma owes all of that same money, so we have to write it all out again. And we have to do this 3 times. Really, 3 times is the best, so that you can definitely be sure that you've spotted the pattern. Now, already you might have noticed that this is similar to what we did with our investment loans. The big difference was that with the investment loans, we had the same number out the front of a lot of our sets of brackets. And here, we've got the principal out the front of this bit, and we've got our payments sitting out the front of the other bits. So this formula for loans is a little bit more complicated, but it's no harder to generate the formula. We just have to tell the story each time. Now in this third month, we took what Emma owed at the end of the second month, and the first thing bank does is charge interest. And then Emma makes a repayment. Now again, we can expand these outer brackets by multiplying this 1.005 by 1, 2, or 3 terms. So let's go ahead and do that. The first one will become 10,000 1.005 cubed. Then we'll have 300 1.005, which is now squared. And we've got 300 multiplied by 1.005 and then minus 300. All right, this is our good formula now for A3. Now, have we got enough information here to build a pattern? I think that we do, and I don't want to write it all out again. So let's see if we can build a formula now for AN. All right, what did we do here? Well, we've got 10,000 out the front of this set of brackets, but the others all have 300s. So it seems like this part stands alone because it's different. Now, how do we figure out what that number is there? It seems to be the same number always, as what's here. So we need to make it n. All right, what about the rest of it? Well, these terms, 1, 2, 3, obviously if we've got to n, there's going to be more of them. They've all got something in common. What is it? They've all got a 300. So let's put minus 300, and then consider what would be in the brackets. We would have 1.005 to a power of something. Now, how did we get the 2 here? It was 1 less than 3, wasn't it? So if this is n, what will this be? 1 less than n, n minus 1. All right, this is 2, this is 1. So next we're going to, now what sign goes here? We have minus 300 lots of this, minus 300 lots of that, minus 300. I've brought the minus 300 out the front of the brackets. So what goes in the brackets is actually plus. I need to add 1.005 to the power of n minus 2, a number that's 2 smaller than the number at the beginning. And I'm going to keep on going with this pattern, dot, 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 until I've got 1.005 just to the power of 1, or just itself. And the last term, it doesn't have any 1.005s, does it? So it's just plus 1, which makes sense because if I expanded the brackets out here, I'd have minus 300 times 1, and our last term does seem to be minus 300 every time. Okay, this is a reasonable formula for AN, but it's not perfect because it's got dot, dot, dot in the middle of it. And so it'd be nice to notice that this part here in the brackets is a geometric series, and we can add this geometric series using our formula. The sum of a geometric series is a Rn minus 1, R minus 1. We need to use that. Now, I think it would be easier to think of this geometric series as starting with the 1 and getting progressively bigger till it gets to its biggest term. I think that makes sense because we can really just flip all of these around. You can do it this way, I just think it makes more sense the other way. So on my next line, I need this part because it stands alone and it's separate from the geometric series, isn't it? So I have that. And now I've got minus 300 lots of something, minus 300 times everything in the brackets. Now the stuff in the brackets can be summarized as this. All right, what's the first term in this series? Because the first term is A. I'm going to say the first term is actually 1 because I'm reading it as being the end one, and I'm saying that's the first, second, third, etc. All right, what's the rate? How do we get from one term to the next? Well, each term is 1.005 bigger than the last one. We have to multiply by that. Okay, now I can use this formula. I've got my A and my R, so I need to multiply by 1. Well, multiplying by 1 doesn't change it. I'm not even going to bother writing that down. I'm going to multiply by R to the n minus 1 in brackets. So I've got my rate to the power of n minus 1 over R minus 1. Now, R minus 1 can be easily written like that. Now, you can write 1.005 minus 1 if you want, but I think it's pretty easy to take 1 off the number just by putting a 0 at the front. Okay, now this is a pretty good formula now. It will tell me the amount of money that Emma owes after any number of months that I want to investigate. So if she says, how much am I going to owe after 12 months? I could just put a 12 in here, and I put all of this in my calculator, putting a 12 where the N is. Now, I don't want to know how much she owes after 12 months. I want to know how long it's going to take her to pay this off. When she's paid it off, the amount owing is going to be 0. So my next step is to actually let AN equal 0. Now, I'm going to need some more board space. So let's start again up the top and get rid of the question. And let's let the amount owing equal 0. All right, that means I need to rewrite all of this with 0 on that side. Now I can see I've got something minus something, so I'm going to do my first step straight off because there's a lot to write here. I think if I add this whole term to both sides, that'll put it over that side of the equation where previously there was just a 0. So I'm going to start with that. Therefore, 300, and I need to write all of this out, is equal to, and then I'm going to put this part. And that's to the power of n. All right, so can you see what I did? I let this part equal this part. Because if one bit take away the other bit is 0, they must be the same. All right, now I'm trying to solve for n, so I need to try and get my n's on the same side if possible. I'm going to start by getting rid of the fractions. So getting rid of that seems like the first thing to do. So let's multiply both sides by 0.005. That'll give me no fraction over this side. And over this side, I need to do 10,000 multiplied by 0.005, which obviously I can do in my head, but I'm just being careful because I don't want to mess it up. Now I want to, well, let's divide both sides by 50. That'll get rid of that. And dividing 300 by 50, I'm going to get 6. That's a nice easy way to do some crossing out. What can I do next? Well, I think I'll expand these brackets. I've got 6 lots of 1.005 to the power of n minus 6. And over here, I've just got 1 lot of 1.005 to the power of n. So if I've got 6 of them here and 1 of them here, if I subtract this from both sides, I'm going to need a little bit more space, then I'm only going to have 5 lots of them over this side, aren't I? So 5 lots of 1.005 to the power of n is minus 6 is going to be equal to 0. Then I could add 6 to both sides. In fact, I'm just going to be cheeky and do that in one step. Let's add 6 to both sides and we'll have that. Now, let's get rid of the 5. How do we do it? Divide both sides by 5. It's getting better and better. Now I can rewrite this as a log, so that I've got n as the subject. So 1.005 to the power of n is equal to 6/5. So I can write 6/5 or I could write 1.2, whatever you like. Now we can put this into the calculator and we come up with n is equal to 36.56 months to 2 decimal places. Then at the end, you've got to consider what makes sense. Think like a bank manager. If Emma's paid off nearly everything at the end of 36 months, is she able to make a payment in the middle of that 37th month? Probably not. So it's going to take till the end of the 37th month before the loan's fully paid off. And we can expect that the 37th payment might be a little bit smaller than the others because there wasn't a full repayment left to go. So I would say, therefore, it'll take 37 months to pay off the loan. Does that make sense? 3 and a bit years sounds round about right.